rational numbers. We talked about rational numbers already. You maybe just know exactly what they are. So rational numbers, here's your first vocab. Rational numbers can be written as a fraction. Okay, so everything we've been doing are rational numbers. Rational numbers can be written as a fraction. Rational numbers can be written as fractions. Now, let's talk about some things that can be a rational number. Okay, so what is considered a rational number? So first of all, integers and negative and positive numbers are considered rational because whole numbers can be put in a fraction. Okay, so integers are rational numbers. Fractions are rational numbers because they can be already a fraction. Decimals are rational numbers, but certain kinds of decimals that are terminating, and that are repeating, can be put into fractions. Let's quick talk about repeating decimals. Just quick. I'm going to get rid of that. So we talked about yesterday these two types of decimals. We said, okay, if I have this decimal, you told me that could be put in a fraction. What does that look like in a fraction again? How would I put that in? Nevaeh. And then I reduce, right? Now, repeating decimals, let's say I have this. How would I put this in a fraction? How can I? No, not no. Because what's happening here? There is a way to put this in a fraction. I'm going to teach you that today. Yep. Nope. Nope, you cannot round it up. Your calculator will round it up for you. But I'm going to teach you actually how to put this in a fraction today. That's the new part. So this and this are two totally different things. Because what's this in a decimal? 0.6. Like two totally different things. So you know how to put these in fractions. You don't know how to put repeating decimals in fractions. And I'm going to teach you that today. Okay? All right, so let's talk about our picture. Okay, so get out your notebook, and what I would suggest you do, let me put this on me. Oops. No, I'm going to teach you how to do it. I would take your notebook, and I would turn it like this for your picture. Okay? It's up to you. Totally up to you, whatever you want to do. Okay. And I will just start my own, so I don't freak you guys out. So this is, let's just say this is my page in my notebook. The first thing I'm going to do is I'm going to make a line on the right side, but I want more space in this area, okay? And that's certain things, so we'll talk about that later. First thing I'm going to do is I'm going to make a circle, but you have to make these big enough that you can write in, okay? So don't make them too small, but big enough you can write in. So my first circle is going to look like this. First circle is going to look like this. And inside this circle, I'm going to write natural. All the numbers that you deal with are considered something. Okay, so the natural numbers are numbers from 1 all the way to infinity. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It starts at 1 now. Okay, so 1 are called natural numbers. Now I'll tell you how we're going to talk about this, what we're doing with this in a second. So you're probably like, why are we doing this? But I'll explain to you. Okay, so natural numbers go from 1 all the way up. Are there any negatives in this? No, it's just from 1 and up. That's it. Next thing, I'm going to make another circle, kind of around it, like this. And I'm going to use a different color. And this circle is going to be called whole numbers. Okay. And this includes 0 through everything else. So like 0 through infinity. So this time, the only thing that's different between the whole and the natural is 0. 0 through whatever else. So like other examples would be 10, 15, 1,000 if you want other examples in there. So 0 to infinity. Yep. But all whole numbers like 3.5 isn't in any of these yet. Then I'm going to take another one and I'm going to create another circle. Okay, another circle around. And this is going to be known as integers. So examples of integers would be what? 1, -1, -100, -500, 3, 6, 9. Okay, so put some examples in there. So an integer would be -1, 0, 7, -1,000. So the integers in there would be your whole and your positive and negative. Yeah, just like what you know. Just like what you know. Yep. Integers are everything that is a positive or negative number. Sure, if that's what you can remember, you go for it, dude. Okay, then I'm done making circles. And on the outside, I'm going to write rational numbers. Because anything in this side is a rational number. Now, there's other things that are considered rational numbers that we talked about today that aren't included in the circle. What are some other the rational numbers that we've talked about that are not included in the circle? Yeah. Sure. So let's do 0.3. What's another rational number? I don't know, 4 and... Yeah, what were you going to say? Sure, so let's do 0.32 repeating. That's a rational number. Another thing would be a fraction. 4/5. 6 and 1/2. 0.932 repeating. Okay, so far so good. So everything on this side of my picture is considered a rational number. Last thing you're going to do is you're going to start here in the middle at natural numbers, and I'm going to make a dot in the middle, and I'm actually going to make an arrow all the way out. Just like that. You're probably like, I don't get why she's doing that, but I'll show you why. I'm not pointing to 0.3 on purpose. I'm just going all the way out to rational numbers. So, how they're going to use this, and we're going to use this in other places throughout the year too. So don't lose this. This is a big deal because we're going to use this again. So what they're going to say is they're going to say, classify 2 as many ways as you can. Okay? So where does 2 fall in this thing? Where does it start? It's a natural number, right? So if it's a natural number, guess what? It follows the arrow out and is everything else the arrow goes through. So 2 is a natural number. It's a whole number, it's an integer, it's a rational number. That's what they're going to ask you today. They're going to give you a number, and they're going to ask you what type it is. Okay? So let's say, give me another number. 4. Okay, they're going to say 4. What type of number is 4? Well, where does 4 start? It's a natural number. Then it follows everything else out. It's a whole number, it's an integer, it's a rational number. Okay, so let's say they say 0.4. Does 0.4 fall any in here? No, it starts here. So what is the only thing it is? It's only a rational number. What if I say, what is -5? Well, where does -5 start? Integer. If it's an integer, it's going to follow the arrow out. And what else is it? It's a rational number. Okay, see why we put that arrow there? Because the arrow is going to say, if it starts here, it's going to follow the arrow out, and it's everything else. A whole integer. So if I ask you what 0 is, what's 0? A whole, so that's where it starts. And what else is it then? Yep. Yep. Okay. See how the picture works. They're just asking you to classify. And everything on this side is irrational. So everything over here can be changed to a fraction. Now what about this guy over here? What do you suppose this area is? Irrational numbers. It's numbers that cannot be changed to a fraction. So irrational can't be a fraction. And examples of this, pi. That's a good example. I mean, we say 22 over 7 is the equivalent to pi in fraction form, but it's not the exact same. It's not the exact same. We just say it's equivalent, it's close, but it's not the same. Anything that goes on forever, 3.1762949111110, dot, 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 that's irrational. Can't be changed to a fraction. There's no way we can formulate a fraction to make it that. Huh? Yeah, a non-ending one, right? Yep, exactly. Okay, does everybody understand how the picture works? Sure. So, I'm going to ask you, 3.2, what kind of number is 3.2? Chance. And what else? That's it. Irrational. Decimals aren't in here. What about 7? Somebody tell me what kind of number 7 is, Larissa. Starts here because 7's included in this. What else? Yep. That's what kind of number 7 is. It's close enough. I know what you mean. Okay. What if I ask you -4? -4, Gabe? Yep. Good job. Aiden. What questions do you have for me on this? Okay, let's do a few other things and then we're going to have to quit. That's okay. So, let's talk about, we kind of talked about this yesterday, we don't need that again. Writing improper fractions. So, a few of these things you already know how to do, but I just need to review them with you. Writing improper fractions. How do I write an improper fraction? If I give you 4 1/2, how do you write an improper fraction out of this? Yep. So, times, and then we're adding. So this, and yep, and then over 2, because that's the biggest thing. Like, people will say, well, I'm going to make an improper fraction, but I don't know what my denominator is. I'm just going to make one up. It's whatever the denominator is. So it'll be 9 over 2. Good. That's the only way. That's literally the only way you can do it for this. Okay. So if I have 5 and 6/7, how will I make that an improper fraction? 35 plus 6, 5 times 7 plus 6, 41 over 7. Good job. What about him? Over 1. Every whole number is always over 1. Yep, good job. Good job. Good job. The whole thing would be a negative then. Yep, the whole thing would be negative. Good. Okay. All right, what about writing mixed fractions? That doesn't make sense. That doesn't make sense. All right, so this is the hard part. Okay, so this is the hard part. This is what's going to take us a while. We might only get one done today. Okay? So let's say that I have 0.88888 repeat. I need to write that a fraction. Write this in your notebook because you're going to need to know this. So a few things you need to know. If there's one, this is the first thing. If there's one digit repeating, we're going to take times 10. If there's 2 digits repeating, we're going to take times 100. And if there's 3 digits repeating, you're going to want this big in your notebook somewhere you can remember, like circle it, like underline it, like highlight it, whatever you need to do. Repeating, you're going to times by, what do you think? Yep. Okay, so that's the first part you need to know to start doing this. It's the first little bit you need to know. Yep, but hold on, we're not there yet. I got to show you how to start it. Got to show you how to start it. All right, so everybody got this somewhere? Okay. Oh my gosh, for some reason that is not working for me. So if you don't get it the first time, if you don't get the second time, hang tight, keep practicing, you'll get it, okay? You might not get it the first time. That's okay. That's how we have to practice this if you're So this is what we're going to write into a decimal, or into a fraction. The first thing I need to do is I need to assign it a variable. Okay, so I'm going to say n equals, and I always use n, the book always uses n for this. I don't know why, you could use x if you wanted to. So I gave it a variable, n equals 0.888888. Okay? What? For this, no, not right away. Not right away. and I'll show you why. And then you could do this on the end, but at least give me a few 8s in there. So now I say to myself, okay, well, how many digits are repeating here? You told me 1 already. 8's the only thing that repeats. So what are we going to multiply by? 10. So what you will do is you're going to multiply by 10 on both sides. And you're like, I still don't get it, but just keep watching. So I'm going to multiply this. You can pretend there's a 1 in front of that n if you want. And I'm going to multiply this by 10. Now this is how it looks. 10n equals, now I got to take that times 10. But when I take times 10, what is my decimal really just doing? Just moving over 1 space, right? That's all it's really doing. If I multiply by 10, it's just going this. It looks now. Okay? This seriously takes practice. Trust me. I'm not done yet because I have to make this into a fraction yet. I'm not done. Yeah. Okay. Next thing. To make it into a fraction, I have to get rid of some of this stuff. Like, I have too much stuff going on here. I'm going to have to get rid of it. I'm going to have to eliminate some. Question? Nope. What you're going to do is you're going to take what we set up here, what 1n was, and you're going to put it down here. 1n equals 8, 8, 8, 8, and it keeps repeating. Because my goal is to get rid of the repeating part. Like, I have to get rid of the repeating part to make it a fraction. So to get rid of that repeating part, what do you suppose I need to do? I got to subtract. I got to subtract. Now, when I subtract this, look what happens. What happens to all this stuff? It goes away. You're right. The only thing that does not go away is this guy, though. If you line up your decimals correctly, this part is the only part that will not go away. So I have this. I'm subtracting. Yeah, but right here is going to be what, Gabe? 9n. Very good. So now I'm on my way to making my fraction. Trust me, we're going to do this many times tomorrow. Many times. Many times. So now, if I want to get my variable by myself, what do I have to do to get the variable by itself? Yeah. Divide. Yes. You're close. I got to divide by 9. Divide by 9. Guess what? That's it. 9/8 in a decimal is, yep, I'm just going to keep it. So if I go on my calculator, if you have a calculator, bring it tomorrow. Seriously. No, not now. You got 2 minutes. If you have it, you don't need a scientific calculator for this. If I take 8 and divide by 9, I get 0.888888888, which is what I wanted to change into a fraction anyway. Okay. So listen, tomorrow, if you have a calculator, bring it along. If you don't, fine. You can sit by a friend that's got one. Doesn't matter to me. And you don't need it for your homework, so it's not like you have to have it. Yep. How did I get 8.88? That's what I wanted to change into a decimal. It was like, this is what I wanted to change into a fraction. And I just drew it out. That's all. We'll do another one tomorrow. Yep. Yeah. If I multiply by 100, it'd be 88. I mean, tomorrow we'll just have you shoot out some random decimals, and we'll change them to fractions. Like, we'll change 0.321 into a fraction. Yeah, we can do that. What is it? I would have to do it out. I'll have to do it out. So listen, no homework for today, okay? Because we're going to come back and we'll practice this again tomorrow. A few times, like a lot.